Hey everybody, today I have the opportunity to talk to you about MVC, and what MVC stands for is Model View Controller. And what Model View Controller is, it's kind of a architecture. It's let's call it an architecture pattern, design pattern, kind of a way of thinking. So it's how you design stuff. It's really not some, software, product, technology. Well, technology sounds like it could be a design, but it's not some sort of software that you use. So it's an architecture pattern, a design pattern, a way of thinking about stuff, just a way of solving problems, not any particular technology that we're using. So some technology we're going to be using to implement Model View Controller is JavaScript, a JavaScript library called Node.js, which allows us to implement server-side stuff in JavaScript, React. We're going to be using another architecture pattern, not a piece of software, called REST, which stands for Representational State Transfer. We're using a JavaScript library called Axios that allows us kind of to do communication, let's call it. And another form of communication much later in the course, we'll be using Socket.io. So again, MVC isn't these technologies. These technologies are just a way of implementing Model View Controller. We can implement Model View Controller architecture without JavaScript, Node.js, React, REST. We can use Python. We can use Flask. We can use whatever we want. So this MVC is not tied to these technologies, nor are these technologies tied to MVC. So we can use JavaScript to not implement MVC, Node.js not implement MVC. So these are just technologies we're going to use to implement this Model View Controller. So what is a Model View Controller? Well, let me grab another screen here. So Model View Controller, as the name suggests, there's a model. And this model is the part that interacts with the database. And I'm using the word database kind of loosely. It could be just a data structure we have. It doesn't have to be some high-fangled database, but it's what interacts with it. And that means it adds and retrieves information. And it's really not concerned with how that information is going to be displayed, with how the info is displayed. I'm kind of want to make these bullets somewhat grammatical. So that's the model. The other thing I should mention, it only interacts with the controller. So there's the Model View Controller. The model interacts with the controller. It doesn't interact with the view. So view, so it's how information is displayed to the user. Doesn't know anything about underlying structure of the data. So it doesn't really interact with the database at all. It doesn't know how we're saving that information. It's typically, when we're using it for web applications, the view is typically done in some form of HTML. And it also only interacts with the controller. And finally, we get to the controller, and I guess you can kind of guess what it does here. It's the interaction. It's kind of the glue that holds everything together. It interacts with the model and the view, and it handles all, let's just say handles all communication. So that's kind of what it is. It's a design pattern where we're separating out code that interacts with the database, that adds and retrieves information. So that code is separate from the code that handles the view, how information is displayed to the user. And the only interaction, so this bit of code doesn't interact with this code, it goes through this controller. So let's kind of take a look at kind of how traditionally that would work and then expand from there. And for that, I'm going to go kind of through a bit of history. So, and I'll even date it to about 1943, when Thomas Watson, the founder of IBM suggested that there would only be a world need for about 5 computers. So that would be it. That would be enough for the entire world. Well, we can kind of argue that that was in 43. But even up until the 1970s, there was a particular architecture that sort of looked like this. So if you were around, or if you knew the parents that were grandparents probably that were around back then, life looked like this. So we'd have, and I obviously need a pen to draw with. So we'd have this server. So some big departmental server, let's say it's the computer science department owns a nice server, big box here with a lot of computing power. And then we'd get little, back then in the 70s, they were just kind of dumb terminals. I guess you could consider them stuff in a computer lab, and that's my drawing of dumb terminals. So very little processing power in these terminals. There could be lots and lots of these. If you were an insurance company, maybe you'd have one huge, humongous computer, and then all the people in this office building would be connecting to it through these terminals, or low-powered computers. So we'd type on this terminal. That would send some information or a request to the server. The server would be analyzing your type and then decide on what to display back to this little client. So if this was the server, these would be little clients. So this makes a request. It goes back. And because these didn't do much, I mean, it captured keystrokes or maybe some mouse stuff, and then it would display information sent to the server. They didn't do much. We called them thin clients. So not a lot of processing in the clients. So really when, even that was back in the 70s, so even when browsers started to appear and this thing called the web appeared, we've kind of followed the same basic idea that we had this big boxy iron thing that was the web server in our case. I'll just say web server. And that interacted with this database. Let me see if I can draw something that looks like a database. So there'd be information here. We'd make a request to the database and put it back. And then we had all these people on their computers, browsers. So these can be clients. Also the browser. And this computer would make a little request of our web server, and this web server would send some HTML, some information back to this client or browser. So if we wanted to look at model view controller here, the model interacting with the data, that's here. How information is displayed is the view, that's here. Whoops, let's put a V there and put an arrow. And this controller was the glue that interacted. So the view didn't know anything about how data was stored, didn't interact with the database exactly. And the nice part here is, if we could change our database, change from Oracle to Microsoft or whatever, it might just impact this little unit here and not be concerned with how the view is. Or we've updated these browsers here, our terminals, and now it can show in color or do something fancy. We just need to change this view. We don't need to interact with this underlying database technology. And this was common, even still is quite a common architecture today. So if we work in basic Ruby on Rails, that's the architecture we're using. If we do ASP.NET, that's the way it looks. And it's not limited here. You can use any technology you want. You can use JavaScript, Node, whatever. We can still kind of implement this idea. So this model view controller, all components are on the web server. These clients are just kind of thin clients. All right, so let me show you another screen here. So what's the new technology? Well, the new technology is this, that we have a server here. We have our database down here. And it interacts with that database. And this part we know is the model. We're still talking about model view controller technology. And now here I have a browser. And I make a request to this server. The server now sends back HTML and then some JavaScript, code that can execute on the browser. From then on out, I'm just going to send some information to the client here, and this client, this browser, is going to be responsible for how it is displayed. So it is taking care of the view. So now we have the view over here. It's not being done on the server, mainly because now laptops are pretty powerful. Computers we have are pretty powerful that can do all this display. We can send minimal information back and forth, and the controller is over here. So that's what the new method looks like. And again, this is an architecture. This is a way of thinking about how to do the problems. It isn't any one technology, but we are going to be using tech here. And let's just write what we're going to be using. So on the server side, we're using JavaScript. We're using Node.js. This interface here between implementing the model, we're still using JavaScript, and we're using a library called PG because we're using Postgres. This is the little connectory part in JavaScript that'll let us use this database. And on here, we're using something called React. So again, MVC, not this stuff in this pinkish color, but this pinkish stuff is just the tech we're using to implement this idea of how we can design programs. So that's kind of it in a nutshell. Okay, so again, model view controller, just a design pattern, not any specific technology. Model MVC can be implemented everything on the server, or it can be implemented this way with some information or some component, the view component being executed on the browser side or on the client side, and the rest on the server side. So let me give you some examples of this in websites of developing web applications. So here's my site, guide-to-data-mining.com, and it's this traditional site where everything is done on the server side. So wherever I click, it's done server side. So it makes a request to the server. Server is responsible for the view and sends that view off to the client. So if I go somewhere else like umw.edu, this is a WordPress site, and again, it's that traditional MVC method of everything being done server side. So when I click on Discover UMW, that sends a request to the server. That server then sends the entire view back to the browser. This is in contrast. Probably the easiest one to look at is Google Mail inbox, where this is different than that. This is where the view is being done after that initial view of initial HTML. It sends JavaScript off to the client, the browser, and then anytime I click, like I click here, for example, and that information is just sent to the server, and just this information of this email is sent back to the browser, and then the browser is responsible for displaying this information. So this is an example of kind of everything, all the view being done browser side. So much so that when Google releases an update to this, a little pop-up occurs saying, please refresh your web page. That's the only way the entire web page gets loaded. Let me go to Amazon. Whoops, if I could type correctly. Amazon.com is sort of an intermediate site where we do get some part of the view being sent by the server, but an awful lot. Let me go somewhere here. Let me pick Bluetooth here and pick something like this speaker. All right. So a lot of this, it's still loading apparently. It's just wait a second. So this here, when I click this arrow, just that little bit of information sent back to the server, and the server then responds with the information needed for the browser to display just this section that I'm scrolling around. So this part here, when I click this arrow, this does not get updated. This stays constant, and you can see that it's just information being sent from the server, just this little bit of information back to the browser. So that's MVC implemented in kind of old school and kind of the way most startups use it. So that's MVC. Let me just open up a new window here and talk a bit more about advantages and disadvantages. And you can't write MVC too much. And let's look at the disadvantages first. And the major one is the steep learning curve. And that's caused by mostly because there's lots of technologies you need to learn. You need to learn JavaScript. You need to learn Node.js. Well, in our version, you need these. We can implement MVC, as I said, using other things, but we still need to learn an awful lot of different things that go together. We're using React. We're using the Postgres adapter and other things there. So it's all these things we need to learn before we can actually implement this MVC where the view part is working on the browser. So that's a fairly steep thing to do. And let me get my notes here. This I don't know. This is what many people say. I'm not sure. I don't know how to pronounce navigability. And what this means is, since the code's everywhere and some of it's running on the browser, it's kind of hard to kind of go through and do debugging. But that, I think, is kind of a dodgy disadvantage compared to all the advantages. For users of our system, there's reduced latency, meaning things load faster because we're just sending very basic, minimal information needed to the page, not the full page every time. For development-wise, one is many people can work on the code at once, right? Because the modules are very well defined. So I can be working on the view, you can be working on the model, and there's very minimal interaction among the modules. That could be seen as another advantage. I'll call it low coupling. So that means that, the communication among modules, there's a very limited number of ways of interacting, and the model and the view never interact directly. Another benefit of that type of design is that within a module, within the model, for example, there's high cohesion, meaning that all the code is related to the model. There's not this interleaving of stuff going on. Now there's ease of modification. That simply means that if I want to change to a different database entirely, like go from Postgres to something like MongoDB or whatever I want to do, I only have to change that one module and not have to do anything to the view. Conversely, if I want to create a new view for users, I don't need to change the model. So there's some ease of modification there. And finally, the advantage of why we should learn this in class is it's what cutting-edge full-stack developers use. So it helps you getting a job and helps you really when you get your job. And just a side note about what full-stack developers are, perhaps almost all of you know it, but I thought I'd just review it. So before I explain that one, they're back-end developers. These are the people that, principally are concerned with the model. They're developing the interaction with the database. They're concerned with kind of efficiency of how many requests can be made. So they know some front-end stuff like the browser stuff, but they're really concerned with the model. Front-end developers, mostly they're responsible for the view. So, and a lot of the time, their front-end work is related to code that's executing on the browser. So full-stack developers do both. They're both back-end and front-end developers. So that's basically it for this talk on model view controllers. So again, the one video we'll be looking at with the model, we'll be looking at technologies where we'll learn JavaScript, we'll be learning Node.js, a very simple library called Postgres, and then the dive deep here is just looking at, I'll just call it database stuff. The other, that's the model and part of the controller. So let me say ANSI. The view part is going to be handled by JavaScript and React. And we can be developing these two things kind of simultaneously. So in class, week 1, we'll be working on some database stuff, be working on how to get servers up and running, and also working on how React works. all independently. There are projects related independently to each of these. And later in the class, week 3-ish, 4-ish, we'll be combining this into one system that is a complete web application. So that's it for this talk. I hope you find it helpful. Next talk, I'll be talking a little bit about RESTful applications.